Welcome everybody. Let's get into it. So today I'm just working on sort of missiles, radar, um, and anything else I kind of feel like seeing how this all fits in. Let's see here. Cool beans. Um, so what I want to start with then is sort of the radar detection system. Right now, the way it works is that when you get within certain range, you'll start to see these different things pop up. Let me change this name, right? Yeah. So what'll happen is, as you get in close, you'll start to see these things. Let me actually want to estimate these or put estimate because they're not exact, or at least that's what we're going to try and set up today is giving them a little bit of randomness. That way, like, as the player gets closer or tracks them for longer, um, we'll start to pick up on these systems a little bit more. So we'll be able to know, like, more accurately this kind of information. But I want to introduce some bit of randomness into these, that we can kind of see, you know, how, um, in real life players, humans, I mean, wouldn't have exact information at first. It would take some time and some basically observation to fully pick up on what's going on. So to do that, that's going to be a little bit challenging, but we're going to get this figured out. So we're going to start, let's get in here, and the easiest ones are going to be the ones that are literally just values. So detection levels, I don't think we need to worry about this one because it's just, yeah, this is how far we detected that ship. So let's do get speed. So what we'll do is we're going to take the error value of the player. So let's see. I know somewhere in one of these we get player pawn. I never have to call to this quite frequently, so what I might do is do a get begin. Or sorry, not get begin, but on begin. On begin play. And on. Oh, is it construct for this, I think? Yes, so it's get construct. Get player pawn. Cast to player pawn. And then we'll just say this. Promote to variable. We'll call it player. And then this as well, I want to promote to a variable. And call it pawn. So this way, anything that is needing these two, I can easily give them. So let's go back in here. And instead of get player pawn, we can just say get pawn. That way it's not constantly pulling for that value. And then in here, I want to grab player and say error, get error radar range, and say this sets one, right? Do I set a value for this? No, so I do need to create a value, so just call it like distance to player. And then make it a float. It's a little long, so just say like dis to player, because everybody knows what this means when this term. Let's see here. All right, so get the distance to player, or no, we'll set distance to player because it's going to update, pretty frequently. And distance player is going to be equal to this. And then go back here. So we take radar range and say, is this dist player? So is the distance to player greater than the radar error range. If false, we just want to straight up do this. So we want to carry on with the perfectly accurate, well, not perfectly accurate, but you know, this is accurate information. We're not fudging it at all. But if it's greater than the radar error range, we want to take the distance divided by the radar error range. So let's grab distance and then take this. Let me just put this over here, and I can just drag from over here, but I like to have it a little bit cleaner than that, and not lines dragged everywhere for the most part. I try to avoid that. Take this, divide by, let's see here. Float by float. Actually, I'm going to take it from this so we're go to the top. So distance to player divided by the radar error range. So this is going to return some number kind of based on, you know, so if this is 1,000, this is 1,000, it returns 1. This is 2,000, this is 1,000, it's going to return 2. So it's basically a multiplicative of how many times outside the radar error range are we. So as we get further, we want it to get worse and worse, which this sounds like it will. So this is the speed, right? So I don't want to do error bars. I mean, making it more inaccurate could mean going positive or negative. But the hard part is you don't want to go too positive or too negative, because then you start to get weirdness. So we make the number smaller. That means as the distance goes greater. I mean, the max distance is still going to be the max distance of detection. So it can only get so far outside the realm of possibility. But what we're going to do is we're going to take this and multiply this by an error factor. And every single one of these is going to have a different kind of error factor. Because, I mean, there's, you know, you can't compare 100 meters per second to, you know, 10,000 tons. That's just not how that works. So let's grab this, and we're going to say, you know, if it's going to go 1 at perfect speed, that means, you know, everything's perfect. But if it's going 2 times, so we want it to be twice as far away from the actual speed, and say the ships are moving at 500 meters per second. Let's start with 10. I mean, a lot of this will probably have to balance later once we actually get in the game, get everything working and running. So what I actually, no, better option. This is, call this promote to variable, call this speed error range. So the benefit of this is that then I can come back in and change this if I ever need to. So we'll start with this and have it set to oh yeah, I got compile first. Whoops. What? To float. Why can I not set the? Am I missing this? Oh, what? Oh yeah, because I'm multiplying into there. So that's why something weirder. There it goes. Okay, I don't know why. I guess I can't click on this. That's weird. Default value. So like I said, we're gonna set to 10. So that'll be. So this will be the. This right here makes the total offset for error. So what we'll do is we'll say speed. I'm trying to think. How do we want to add or minus the speed? I guess we don't want it flip-flopping constantly. That might look a little jank. And high speed is everything. So we're going to say we'll add it to the speed. So if outside of radar error range, we're basically going to do the same thing for this and grabbing all this. But before we get to toText, so we're going to want our own another return node. So return node. And we're basically going to take from here and add to the output of here. So that way we can get the error range added to the actual velocity. The hard part is we do need to add some kind of randomness to it, right? The way it works right now, this will always be constant. So if you know your distance, you can kind of roughly guess what their actual speed is. You know, if you know you're 2,000 away, you know it's gonna be about 2 times. So that means that you're actually only gonna be this fast, like I guess we could take error range and add in. So this is base error range. And then we could add in a variable. So random. Shoot, actually, let me grab it from the. I have a better way of doing randomness. Actually, is it in the player one? Trying to think where I did randomness. I know I've done it in one of these. Oh, was it naming the ships? Yes, I think it was actually naming the ships, which that's gonna be in the AI. And yeah, here we go. Random integer range. I'll just grab these two. Actually, I don't even need these two because I'm just doing a random integer range. Targeting. There we go. So we'll grab this. All right. So we're gonna grab minimax. So the minimum it can add to the base error is 0 because 10 can be the minimum, and the max it could add will be. Actually, no. Perfect way to do this is negative 50 and positive 50. Because then the base error can help reduce that. Well, if we do base error times a certain number, then yeah. Because if the base error ever gets to 0, it would be perfectly accurate. So we'll do base error multiply. But I guess if we did float times an int, so times int, move these two up. So then if we do, say, times it by 5, and you get a positive. Wait, we want to do positive. Twice times anyway, int doesn't already return. I guess it wouldn't return it. And then timesing it by a negative 5. And that'll give you a minimum. So take this and do there. Oh, that's going to be required either way, but I could actually change the base error range into a integer, and that might actually help reduce the amount of like excess here, because I don't need these truncates if I do that. So let's just change this to an int. Because I mean the error range, I mean, I don't know. Like 10, that's I I might leave it this for now in case I want to make things like more gradual, like 0.5s and stuff. But I might change that later. We'll figure that out later. So this will give a little bit of randomness between -50 and 50. And in fact, let's move these around so that way that looks a little better. Yeah, there we go. And it takes that and multiplies that by the distance. So if it got -50 times 2, that's going to be -100 that then gets added to the speed, which that's not too bad. And then we will to text this. Let's line these two up and drop that there. All right. So if it's true, it'll go that way. So if I've done this right, the speeds of these ships should all be slightly off from 0, because right now they're not moving. So they all should be slightly off from 0. Estimated speed's sitting at 0. Let's see if I get further away. But I'm still under that threshold, right? So let's set that threshold to much lower, just as an example. Radar error range. Let's see. Oh, it's in the player, that's right. Radar error range is currently set to 1,000. So that player stats. Let's drop this to like 10, because then as you know we get close, it should pretty much immediately be off, and then as we get closer it should correct. So let's see. So it's still saying speeds are 0. Huh. So why are this estimated speeds not changing? So if players distance to the player is greater than the radar error range, so greater than 10. I wonder if I need to set it from here instead, because I think this one is giving me a very low value because doing kilometers. Or at least that's the goal, is to do kilometers. So let's see if doing that actually improves that. Yeah, now that's really high numbers. Should not be. Oh, but it's multiplying, because it's multiplying by how big the distance is. So. Let's try going in here and let's do something a little bit not so crazy. Let's drop this to like -2 by 2, and then set this multiplier to not so crazy. So this is distance to player, and then radar error range, which is on player. So we'll switch the radar error range back to something more reasonable, like 500. Let's see. And at first it should be pretty far up. But then as we get closer, it's fluctuating quite a bit. It's because the UI is updating extremely frequently. And then as we get within a certain range, it just drops off back to normal. But I wish it wasn't fluctuating quite so much. I don't want it to be changing that frequently. I just want it to be like let's see. Is there a way to like delay this? I don't want this text updating nonstop. Let's just try. plug in delay in and see if that. Oh, can I not set a delay in a widget? Huh. Didn't think that was a thing. Let's see. Let's take a peek and see at the API here for widgets. Oh, I think it's because I'm in a function, but you can't do delays function, so that makes sense. But also, I don't think there is a way to delay because it's directly in the update. Unless we, instead of binding all these, if we just updated these separate. Let's see. Unless we made it not random and just had a set radar, but that's, I don't know if that's really what I want to do because that's too easy to kind of game and like. But if I skipped over the error, could call it do once for the random part, but well, maybe would that work? Or I do once, just lift all this up and do a do once. Wait, but I do a sequence maybe. So do once, and this thing's only job is to do once is to actually alt that. Is to take all this, so it's gonna run this, but it's gonna turn it into a variable. So I'll promote to variable and call this random offset. So this do once is called, since they're and then if oh wait, yeah, we don't want it to go all the way. So the do once is called, sets a random offset. Then we're going to take the random offset and grab it, get random offset, multiply it here. So yeah, there we go. Then this will go into return node. So this will have a one-time random offset, and the only time it resets is when the player here is then within the error range, so they're closer than error range. It resets the random value, or the ability to generate the random value. Yes. And then goes here. So, yeah, that sounds pretty good because then it still leaves room for pretty far off numbers. So I say like -5 and 5. So let's see what this does. It should only randomize once, and then after that, um, the do one shouldn't get called again because it should just automatically be like, oh, can't do this. So it'll skip down to 1. Hopefully, that should be right. If I understand the do once correct. Nope. Okay. So let's see here. Yeah, 'cause I'm only wanting it to reset once I'm within the error range, but seems to be. Well, I guess I could call the do once on construct, right? Let's see. Can I actually call this on construct? Control X and then go to event graph on construct. Call the do once and do this. And then event destruct would be the only time it would reset. So then we come in here, and then we don't actually need all these because we can just go straight on through. If true, so if distance to player is greater than the radar error range, then add that random offset. So it should only do it the one time. Yeah, so as I'm getting closer, it is the distance is going down, so the multiplier is going down. So that's why those numbers are changing as they get closer. Which isn't necessarily what I'm wanting, because it's kind of inaccurate for it to change like that. So maybe this would be better as yeah. As cool as this is, because it means the further away you are, the less accurate you are. It's changing instead of staying solid. And I'd only want it to change at certain jumps. So maybe if I did rounds or switches, I could do a switch on a float. I don't think that's the case. Yeah. Let's see. What could we do as far as let's see if I did switch on int. So if true, I would actually take this and turn this into an int, so truncate to an int. So let's grab all this. Or actually, no. Because I don't want to do it there. I want to actually do it all the way back here. So the distance to player. Let me actually remove this. So distance to player. Get distance. I want to truncate it down to here. Oh wait, no. Also wrong. I want to take the multiplier, so I want to get this part, truncate to here. So this will give me different numbers. So the multiplier, we'll probably want to have a max multiplier. So this one's got to jump in speeds. So as you get closer, you'll get more accurate information. So, yeah. So what we want to do is, instead of this updating constantly and giving us new values, we want to take this. In fact, all of this. Basically, we want to multiply it depending on which one of these is the case. So what we'll do is we'll add distance multiplier. Yes. And then we'll set it depending on, you know, this probably won't get called for certain values, like 0 I don't think it should get called. Because 0 is going to be close enough that it goes here, and probably even 1 it probably won't get called, but I'm still going to include them here on the off chance it does. So add distance multipliers. The highest one will be 4. So what this will do is, depending on how far away you are, this should multiply the error bars. Actually grab that as well. Let's lift this up, over. Grab these two and pull this down here. So, so no matter what, it's gonna pull into the return node, because we are gonna go that way no matter what. So let's grab this. Yeah. And then there we go. And then for here, we just add the multiplier, so distance multiplier. So actually, since we're doing this, we don't actually need to do that. We'll just do multiply int by int, random offset. Then turn that into a float to add it to the other float, because we're adding it to the actual distance. I mean, kind of would want the random one to be a float rather than a int, but we'll figure this out. We can always change some of these, like the float to ints. We can always change later. Here we go. Still good on time. So in these ones, of course, set to 0, and the 1 they're going to be just set to 0 and 1, which these are probably never going to get called, but you know, for error correction purposes. And here we're going to set that to 2, set this to 4, set this to 8. Those are a pretty large number, so it'll be quite a bit off, but we'll see how that works. Alright, so times and then adding it, so that should work. So, you know, as your and then the default. Because default is anything that isn't one of these. So that means most likely greater than. So our max is going to be the 8, so we'll plug that in there. So let's see here. Alright, this should work. So what it'll do is, as we get closer, it will shrink down. Now, I don't know, might have to shrink this, but we'll see. See at least where it starts off. Make sure it's not rapidly changing as we move in closer. So right now it's saying estimated speed is -8. Then this should drop -4. 0. Right, so yeah. Then it has to move away. -4. -8. It's -16, and then it blanked out because it got up too far away. So that should be about right. Now that sounds like a kind of a dumb number, but that's just because the ship's not moving. So let me see. Actually, probably want it to be a little bit higher than that, though. Um, so distance multiplier multiplied by the random offset. Random offset is an int. Yeah, because these numbers would only the big thing is they're removing from a speed. So if the ship was going like 22.5 meters per second, it would then change to like 18.5 or something like that. So with it not moving, this should be fine. We'll have to do some more heavy testing once we get the actual ranges more dialed in, because the goal is to get all these systems in place and then dial in these systems a little bit better. So let's see. So I think that's pretty good though for the speed. So the speed's kind of randomly offset now. So let's take a look at tonnage. So tonnage, we are just getting in the, I believe, just getting a setting on, yeah. So the variables from the class itself, which gets set. So we actually want to have a binding for that one. So instead of tonnage, we'll want to create binding. And we'll call this get tonnage. So the actual tonnage is still going to be set by the player ship. Well, I say that it's not actually being set by the player ship, but I'm essentially temporarily, I believe the player pawn in the begin play is, no, did I actually move it? Okay, so I moved it all to the ships themselves. So I moved them all here, so that way these can be edited. So in here I can set the actual tonnage, and I'm eventually going to open these up, make these settable on spawn and things like that. But for now, at least, this is setting the tonnage. So the ship's actual tonnage comes from there. And then in here, we want to take that tonnage and do something kind of similar to getting speed. In fact, the random part we might even keep. So let's see here. Yeah, so depending on the distance to the player, we still want to do a lot of this. In fact, pretty much all of that. And then let's see, distance multiplier, random offset. We won't do random offset to that same, because that's going to be random speed offset, which I'll probably change the name of. But we do want to do something very similar. So I'm going to grab all of that, Control C it over to get tonnage. And then we'll do this. All right, so distance and radar range. If false, get the exact tonnage. So if false, return node. Return node, and that's just pure tonnage. We just want the actual tonnage of the ship. So if we're within radar range, that's accurate. We'll just give you the actual tonnage. But otherwise, we're going to want to do some level of randomness abstraction to it. So let me see here. Let me actually change the random speed offset here. There we go. So with the tonnage, let's see. So let's do distance multiplier by negative 500, right? So the biggest multiplier would be 8. So let me see, 8 times negative 500, is that outside the reasonable? So negative times I guess 8 times 500 and then just make it negative. So 4,000 is the most it can minus, yeah. And then we'll do on the event graph, this will be, call this random tonnage offset. And basically we'll do basically the same thing between, hell, I mean, you can do the same thing. You can just change this to base error rate. Because then we have one variable that we can edit in the radar that would help improve the player's able to read. So let me set it here. This would call it again, so it'd be a different number because it calls another random integer in range. So that would be the offset between negative 50 and 50. How would I want to use that random tonnage offset? So instead of this, oh yeah, instead of the negative 500, so what we can do is take the random tonnage offset. And actually, yes, so what we can do is go in here and actually take this value and times it by another 10. Because then we get between negative 500 and positive 500. Yeah, times by 10, because if it's if it's 50, you get 500. If it's negative 50, you get negative 500. So yeah, that works perfectly. So then in here we'll get so this offset of the tonnage times by the actual tonnage, and because that's all done in begin play, it only resets when destruct. So yeah, because it's gonna be multiplied by the distance multiplier. Yep, which is all correct. So then these all plug into here, and then tonnage plus the distance into the float. That should be correct. So we should start to see the tonnage then be different depending on our distance. So it's saying the estimated tonnage is 100 for one, 1800 for another, and 1200 for another. Perfect. And that's kind of how, yeah, look at the estimated speeds also doing the same. So perfect. Let's get a little closer. As we get closer, it'll get more accurate to the actual tonnage. See, bam, all to 1,000 except that last one. So yeah, perfect. That's pretty much exactly what I want. As you get far away, it gets way off. Like that one's saying almost 2,000 tons. Perfect. Double its weight. And then, all right. And the big thing is going to be, ships' tonnages can be wildly different. So we'll probably also have that 10 number. It'll actually be a size multiplier. So depending on the size of the ship, that'll actually determine this number. So in fact, I might even make that a promote to variable. What would I call this though? Like a ship class multiplier? Oh, yeah. So okay, this is probably adding a little bit too much complexity, but just add another int here. This goes into here. So we'll have one be a variable that is ship. Oh, actually I hit enter. Ship scale multiplier. And then this will be times 10. So large ships, so if you have a ship of size 1, which these basically will be, so we'll set the default to 1, you get times 10. But if it's a huge ship, it's going to be a 10. That means it's 10 times 10, so it's 100 times that. So you're talking about like 50,000 swings either way, right? Because that's, again, I gotta get a calculator out because I'm awful at math. So right now, if it's a size 1 ship, it is times by 10 which then gets multiplied by either 50 or negative 50. But if it was a times 10 ship, so 10 times 10, you're talking about 100, then timesing that by 50. Yeah, you're talking about swings of 5,000, or even higher. You know, if you set that scale up, so that scale is going to really determine how wild the swings up, which that's perfect. In fact, that might be one you can set as the player, so that makes sense. Or not player, sorry. This one will be able to set in here. So actually set the ship scale. So in fact, let's move this all this way. So yeah, a lot of these variables get set at the beginning, but I'm not worried about setting it now, but later on we can add in, you know, ship scale being set here. All right. So let's see. So, and in fact, we might not have to do this. So this is done for some of this, but some of this I may change, and then each class, you know, as we make a child class, they can set their own things in here. So you know, a cruiser could set its speed to or its size to a certain scale. Um, but the default works for like freighters or whatever, which are probably one of the more common ships. But that kind of thing. So that makes sense. All right, so I think, let's see here. All right, and let me see. So now the detection system's starting to influence what the player knows. So let's see, we've got the speed, we've got the tonnage. We still need to work on the thermals. And in fact, the distance I'm not going to estimate because I feel like that's one of those things that players need to know. Plus, it's not that big a deal. If it's not too randomized, I can always like add a little bit of randomization later, but honestly, I kind of like player knowing the exact distance because in reality, with like laser pinging and stuff, that if you're discreet enough, you could easily know the distance. But this is going to be, you know, as you get very far out, I might add some flexibility to this. So like if you detected the enemy, but they haven't detected you, you're not actively pinging them, maybe there's some additional variance to the distance. But we'll see. And then these I'm going to change eventually to where like if you only have a certain number of detection. See, the detection time is also going to start to impact these as well. That's just going to take some time to actually implement into this. But as you detect them for longer, you'll be able to narrow those down. So we at least got two of the two values working. So what it'll do is the detection time will probably have a multiplier here where it'll like divide this by a certain amount so that as you detect them for a really long time, it'll start to divide from here. So, all right. I think that is everything for today. At least I might work on this a little bit later, but I don't know if I'll stream it just because I'm pretty busy today. But I will see you guys next time. If you haven't subscribed already, go ahead and do it down below. Make sure to leave a like and comment if you haven't as well. That always helps out the channel when I'm trying to live stream and record as well. If you have any other questions, definitely leave them below. Thank you. Peace out.